Okay, this is for problem number 4, and it's the same as problem number 2, or the one that I did. I'm not sure why this is for, but anyway. Okay, so you got to identify the intermolecular forces in each of the following molecules. So the first thing that you want to do is to draw the Lewis structure. So water, you've probably drawn it a lot, but it's going to look like this. Okay, and so water is bent. And because it's a bent molecule, because it has lone pairs in the central atom, it makes it polar. So we know that water has London dispersion forces because everything has that. Because it's bent and polar, it also has dipole-dipole, and water can hydrogen bond. And the reason that it can hydrogen bond is because it has a hydrogen bonded to an oxygen. Remember, it's FON, and so that's why it can hydrogen bond. Okay, B, CB4. So you draw that one. So if you draw that, you end up seeing that that's tetrahedral. I'm not going to put all the lone pairs on it, but because it's tetrahedral and all four things are the same, it's nonpolar, so it only has London dispersion forces. Okay, C is NaCl. Well, NaCl is a metal. This is a nonmetal, so that means it's ionic. So what this is going to have is, remember, sodium is going to lose an electron and become positive 1. Chlorine's going to gain that electron and become negative 1, and there's an ionic bond in between them. Remember, ionic, or not ion, ions go in brackets. Don't forget your brackets. This would be an ionic bond. Okay, PCl3, if you were to draw that, it would look something like this. I'm kind of leaving off the lone pairs on the chlorines, but anyway, you would end up getting that it would be a trigonal pyramidal because it has this lone pair on the top here. So it's pyramidal. And all pyramidals are polar. So now, everything has London dispersion forces, but because it's polar, it has dipole-dipole forces. You can look at the flow chart if it helps you to go through this, but it's polar, so does it have, okay, so we're going to see if it has hydrogen bonding. The answer will be no, and you can see that here. So in order to have hydrogen bonding, you'd have to have a hydrogen, which this one doesn't have, so can't have hydrogen bonding. Okay, CH3OH, that's called methanol. So basically you would get this Lewis structure for this one, and then you'd have an O and an H. There'd be 2 lone pairs there. Okay, so that's the Lewis structure for that. And so if you look at that, it's kind of hard to do the shape of it because it's just it's kind of more of a complex molecule. But it is polar because each side is not the same. So it does have a polar part to it. Okay, and so it's polar. We know everything has London dispersion forces. Because it's polar, it has dipole-dipole forces, and it has a hydrogen bonded to an oxygen. That means it can hydrogen bond. Okay, and K solid is just an element, but okay, it doesn't really have any thing with it, but everything has London dispersion forces. Okay, everything has London dispersion forces. So anyway, that's it for this video here.